Hello and welcome to Math World. Today we're going to talk about graphing with slope-intercept form. We've seen slope-intercept form before. We remember it is y equals mx plus b, where m is our slope, b is our intercept, and x and y are just the two variables that we're comparing. Alright, so we had this equation, and now we're going to graph with this equation. We've actually seen this before also. When we did the graphing with the graphing calculators, we were entering the equation, and we got to see the line move. We were able to control it. Remember, we were kind of like math wizards. We made the line go up, we made the line go down, we were able to change the slope. Well, let's see exactly how it's built using slope-intercept form. Let's start with something simple like y equals 2x. Now we learned in class that the slope is also called rise and run, rise over run. This slope of 2, a slope of 2 could be written also as 2 over 1. So we have a rise of 2 and a run of 1. This is going to help us build the graph piece by piece. Now first, where should I start on this graph? Well, I need a starting point. We talked about the intercept is our initial value. It's where the line will cross our y-axis. So, what is our intercept of this equation? Y equals 2x. Where's the plus b? It's plus 0, right? If they don't have it, it's just plus 0. That means that our first plot is right here at 0, 0. Very simple. It's going to start at 0 and 0. Now, where's the next plot go? This is where we use our rise and our run. Our slope will tell us how to move the line. We will rise 2, run 1. What that means is go to your intercept where we started and go up 2 spaces. We just rose 1, 2, and then run 1. Which direction should we run? We will run the same direction that we read the graph, from left to right. We'll run 1. And right there where we land is where our new plot will be. So you see we have a rise of 2 here and a run of 1 here. Rise 2, run 1. Right now I have a line. Really, I have enough to build my line too. I'm not going to build it yet though. I'm going to do another one. Starting from this point, let's rise 2 again. 1, 2, and run 1 again. And I'll land right here. There's my next point. I can do it again. Rise 2, run 1. And now the next one will take me off the graph. These 4 points here are enough to create a line. If I would draw a straight line across these, boom, there's my line. It's that simple. Use the slope to build your line. We can actually take this a little bit farther. This line that I just drew really could be extended as far as I'd like it to go. It can go all the way up and down in any direction. There we go. Up 2 over 1. Up 2 over 1. I built the line. Let's try to make it a little bit harder. What happens when I have y equals 2x plus 4? So my slope is 2. I haven't changed anything with the rise and the run. What have I changed? Well, I've changed the intercept. I've changed where I'm going to start. So this is now going to not start at 0, but instead start at 1, 2, 3, 4. It's going to start at 4 on the y-axis. My first plot will go right there at 4 on the y-axis. Now, I do the same thing I did before. Rise 2, 1, 2, run 1, run 1. New plot. And now I'm all of a sudden off the chart pretty quickly. I'm not too comfortable just creating a line with 2 plots. I'd like to have a couple more. So there's actually a trick where instead of rising 2, running 1 to the right, I can go backwards. I can reverse both of these. Remember we said sometimes when it comes out a negative on top and on bottom is the same as positive top and bottom? Well, what happens if I had a negative rise? Well, a negative rise would take me down 2, and a negative run would take me back 1. That works also. So now I have negative rise 2, negative run 1. And look at this, the line can kind of build itself backwards. It's going to build itself backwards. And I'm doing this because I kind of ran out of room up here. I didn't want to just leave 2 points. I wanted to make sure I had a nice solid line here. Now I'm going to connect them, and there's my line. Boom. What do we notice about these two graphs? Well, they have the exact same slope, 2. The exact same. The only thing different is that this second graph actually crossed the y-axis at 4. It's a little bit higher than the first graph. That's it. We're just starting at our intercept and moving by our run. Let's look at 2 more examples if you have the time. What about y equals 5x minus 4? Does this minus 4 make the graph negative? No, the slope is positive. It's the slope that decides up whether the line goes up or down. This negative 4 just means we start on the y-axis at 1, 2, 3, negative 4. I'm not starting in the positives on the y-axis. I'm starting the negatives. Next, I did the exact same thing. My slope over here is 5 over 1, which means I'm going to rise 5. 1, 2, 3, 4, 5, and run 1. There's my first plot. Do it again. 1, 2, 3, 4, 5, run 1. There's my next plot. And this one is pretty steep, so I've already got my line. Boom. Comparing this line to the last 2, we notice it's a lot steeper. That's because the slope is a lot higher, 5 versus 2. And we have an intercept of negative 4. Last one. Y equals negative 5 plus 6. So here, where are we going to start? Well, let's look at our intercept, and we'll start at 1, 2, 3, 4, 5, 6. And this time we have a negative slope. This means negative 5 over 1. Unlike before when we made both of them negative to match with a positive slope, here we're going to leave the 1 positive because we want our slope to stay negative. The 5 will be negative, which means we're going to go down 5, 1, 2, 3, 4, 5, a negative rise of 5, yet that 1 is positive, so we will still run to the right 1. Yep, that's right. See it again. Down 1, 2, 3, 4, 5, but run to the right 1. Instead of what we did before when we went down 1, back 1, because both top and bottom were negatives. Here, our slope is negative, so only one of our ratio is negative. Let's go ahead and just connect these. There's my line. And that makes sense because we have a negative slope, so our line should be negative. Graphing with slope-intercept form. Well, that's it, and I'll see you in class. Now for a word from our sponsor, Papercut Games. This week's game, Castle Panic! This game is so cool because it's a tower defense game. I know some of you have played tower defense games like Balloons Tower Defense on Cool Math Games. It's just like that, but it's a board game version. Tower defense is when you have this tower in the middle. If you look at this picture here, in every turn there's different enemies that attack your tower in these different waves. And so this board game version, you actually will draw these little tokens out of monsters, and the monsters will come out, and every turn you see they're surrounding your castle, they'll get closer and closer and try to blow up your castle. Now another cool thing about this game is it's cooperative, meaning everyone who's playing is on the same team to protect the castle. And you guys will draw these cards, like this hero here or this barbarian, and you will play the cards to destroy the monsters as they come out and try to protect the tower. It's a great game because it's cooperative, so everybody wins or everybody loses, and you got to work together. Really fun game. Check out Castle Panic.